Okay, derivation of mirror's formula. Now for a converging mirror, prove that what we want to prove now is the mirror's formula. Prove that 1 over u plus 1 over v is going to be 1 over f. Then where all the symbols have their usual meanings. So where all the symbols have their usual meanings. Now again, reduce the mirror's formula above to a plane mirror. Then comment on your answer. Now this is standard IJMB question, so all we need to do at this point firstly is to look at this. Okay, the mirror's formula. In the mirror's formula you have 1 over u. That u represents your object distance, while the v represents the image distance and f represents the focal length. So we have to derive an expression for this. We have to show that 1 over u plus 1 over v equals to 1 over f. So the first thing that we need to do here is, for you to show this, you need a sketch. A sketch where you have a converging mirror, where you have the center of curvature, where the image is located, where the object is located, and you have your image distance, object distance, and the rest. Then we can now apply some mathematical calculations or idea to bring out the mirror's formula. So let's have this. For this now we can have the length, which is the basis of the diagram. Now you can have a mirror in this form. This is a converging length, so you have this. At this middle you have your straight line, and this straight line at this point you have where the object is located. Then object is located at this point, so you have distance from this mirror to where object is located, so that is object. Then you have the center of curvature. We call this C, center of curvature. You have where the image is located. Image is I. Then you have this part. You can just trace this down, dotted line as the normal end, and this place to be taken as P, and this dotted line we can take this as H. Okay, at this point these are angles, so we call this theta. We can call this also theta, and between this, call this first angle alpha, call this second angle beta, and call the third angle here, which is here, gamma. So 3 angles are available. Now on this plane mirror, when you are from this part where you have the object to that point where we have the plane mirror here, is known as your object distance, which is u, object distance. Now from this plane mirror also to where you have the image, that is known as the image distance v. Then from this plane mirror also to where you have the center of curvature, which is C, that part is known as R, which is the radius of curvature. So let's take this other part here as point. x. So if you look at this diagram now, we have O, X, C, which represents object, where the object is located to the center of curvature. Then you have X, C, I, where the image is located, and you have X, I, N as the normal. So if you consider now from that triangle CXO, CX back to O, what do we have there? You are dealing with the object, which is angle alpha, but mathematically sum of exterior angle must be equals to what? Sum of interior angle. So the exterior angle is sum of exterior angles must be equals to sum of interior angles. So what is the exterior? The exterior is this angle that is outside, beta. That is exterior, outside. Then interior means the two angles inside, theta and alpha. So exterior is beta equals to interior alpha plus theta. So it is possible for us to make theta the subject of formula. Is that? So if you make theta the subject of formula, now theta is coming out, so you can have theta will be beta minus alpha. You take this beta to the other side for theta to be called the subject of formula. Call this equation 1 from this diagram. Again, if you consider from triangle IXC, again go back to the triangle IXC. This is it, IXC. The exterior angle there is what? Gamma. And gamma, you have the interior angle to be what? Theta plus beta. IXC. So you are going to have it that what? Gamma equals to beta plus theta. So you can also make theta the subject of formula. That shows that theta will be what? Gamma minus beta. Call this equation 2. So all I need to do now is to equate equation 1 and equation 2. So what do we do there? Equation 1, you have the first theta to be beta minus alpha, while equation 2 you have the next theta to be gamma minus alpha. So equate that first one, equation 1 now. So we have beta minus alpha equals to equation 2 gamma minus beta. Is that? So what is common here? You have beta beta. So bring the beta and beta together as if we are collecting like time. So you have minus gamma alpha minus gamma equals to minus beta, again minus beta. So here you have minus, you can factorize out negative. You have gamma plus alpha, because negative times positive will give you negative, equals to minus, again factorize this out, beta plus beta. So here negative, here cancel this negative, so I have alpha plus gamma equals to beta plus beta will give you 2 beta. Call this equation 3. Now by trigonometric ratio, by trigonometric trig ratio, you have it that for triangle XON, so we need to go back to the sketch. XON, what am I going to have for that? Let's cut this part down. xon, when we go back to the sketch, you have it that xon is alpha, which is xn over on, which is the same thing as xn over op, and everything is still same as h over op. Let's check the diagram. So we said for xon, x o and n, x o n, that is a like triangle. So you can say you have x n over o p completely, as if you consider the whole triangle x n o p 1. Again, you can have x n, which is the height, and c p. You consider the inner triangle again. Now if you consider the last part, xn itself is what? H, and cp is still same thing as your what? op. I mean xn over on, that is for that triangle, then xn over c op. Let me take it again so that you can get the xn over o n 1, then xn over o op completely. Now that is for xon. Okay, so if you go back to that part, that is same thing as what? H over op. Okay, for triangle xcn, same way you can have it that is talking about beta, the interior angle there. Beta is still xn over cn equals to xn over cp, which is still h over cp. Then you consider the last triangle for triangle xin. So you have that inner one to be gamma, which is xn over in equals xn over ip, and that is still h over ip. Let's go back to the sketch. Okay, when you consider xon, the interior angle there is alpha, so alpha now equals to xn over all the distance there is what? op1, which is still same thing as xn over on, where you have the image, which is still same thing as xn itself is height. Instead of xn now you replace it with h, which is h over op1. If you consider triangle xcn, you are going to have xn, take height first, over cn. At the same time, you are going to see have it as xn, which is still the height, over cp. Then lastly, xn is h, so you can have it as h over cp. Again, you can have the last one, the interior angle is gamma, which is xin. So xn over in, the little part, again xn over I to the extreme end p, then xn is h here is equals to what? Over ip. Okay, so to the next page. Alright, so at that point, substitute the value of alpha, beta, and gamma into equation 3. So we now substitute alpha, beta, and gamma into equation 3. What is equation 3? This is our equation 3 here. So anywhere you see alpha now, alpha is h over op. So you have 1 h over op. Anywhere you see gamma, gamma is h over ip, h over ip equals to, then anywhere you see beta, beta is h over cp, but there is 2 behind that, so you have 2 in bracket of h over cp, close the bracket. Now we'll now go back to the diagram. So if you look at the value there, if you want h over ip, just look at it from here first. OP represents u, that is object distance. So anywhere you see OP, it is to be u. Anywhere you see CP, it is to be taken as radius of curvature r. You can see that. Then anywhere you see IP, it is to be taken as image distance, which is V. So go back to that part. Next page now. So in that last equation, what we had was h was common out through. So if you bring out h, if you divide by h, so you are going to have what? H over 1 over OP plus h over 1 over IP equals to h in bracket of 2 over CP. So h cancel h cancel h. So I'm left with 1 over OP plus 1 over IP plus equals to 2 over CP. Note, OP represents U from the sketch. IP, image to the point of that, represents V, and CP represents your radius of curvature R. So if we fix that into this, fix all this into this, you are going to have what? 1 over OPU plus 1 over IPV equals to 2 over R. But what do I need to recall here? R is your radius of curvature. Remember, F focal length is R over 2. That shows that R will be 2 of F. So if you put anywhere you see R here, turn it to 2F. That makes this formula becomes 1 over U plus 1 over V equals to 1 over 2 over 2F. So what happens here? 2 cancel 2, and that gives you the Mirror's formula, which is 1 over U plus 1 over V equals to 1 over F. Now proved. Now take note of something. The next part of the question is now reduce this formula to a plane mirror, then comment on your reason. But for you to reduce this formula now to a plane mirror, to reduce it, the mirror's formula above, what you must recall is that for a plane mirror, the focal length is always at infinity. So therefore, what happens there? If the focal length is at infinity, recall the mirror's formula 1 over U plus 1 over V equals to 1 over f. So that gives you 1 over u plus 1 over v. Everything gives 1 over infinity. And 1 over infinity is going to be what? 0. So that other part is left. You are left with 1 over u equals to negative, if you take this to the other side, 1 over v. So if you take the inverse, so you have u over 1 equals to negative v over 1. That shows that what? U is what? Negative v. So what are we trying to say here? The negative sign shows that what? Indicates something virtual. So that means a plane mirror which have the object to be real produces a virtual image. So the negative sign, indicates virtual image. That is, a plane mirror forms a virtual image. And it is still possible again, aside that, for you to now work on that formula, which is 1 over u plus 1 over v equals to 1 over f, to derive other expressions for magnification. Okay, so and you call that magnification m. Magnification is size or height of an image over size or height of an object, which is object distance, image distance for object distance, or image height over object height. So this is magnification. So from this part you can reduce this formula, this mirror's formula, to get other expressions for magnification. So it is possible to do that through, okay, if you multiply equation star above, multiply through by, if you multiply through by v, so you are going to have what? V times 1 over u plus v times 1 over v equals to v times 1 over f. So what are you going to have here? V over u plus v, cancel v here, I'm left with 1 over 1 equals to v over f. So v over u here represent m, magnification. So plus 1 equals to v over f. So that can give m now to be v over f. If you take that 1 to the other side, minus 1. This is an expression for magnification from the mirror's formula. And similarly, you can still say but f, which is focal length, is radius of curvature over 2. So anywhere I see f here, I replace it with r over 2. So that gives m equals to v over r over 2 minus 1. So that makes it to be m equals to v divided by r over 2 minus 1, which make it m equals to v times 2 over r minus 1. And finally, you can have another expression for magnification as 2v over r minus 1. So this gives you another expression for magnification. So what do I need to note here? Take note of the following. So note that a convex mirror has a negative focal length 1, a concave mirror has a positive focal length 2, image distance in a convex mirror is negative 3, image distance in a concave mirror is positive except when the object distance is less than the focal length. Note that image distance in a concave mirror is positive, but except when the object distance is less than the focal length. Again, distance of real objects and images are positive. Then distance of virtual object and images are negative. So once you can recall all that, then you'll be qualified to take one or two questions on this. So we can have examples. So here now we can have an object. I'll read out the question. An object is placed 10 centimeters in front of a concave mirror. An object is placed 10 centimeters in front of a concave mirror of focal length 15 centimeters. Now what is the position and nature of the image formed? So one thing that we need to note here is an object is placed 10 centimeter. Object is placed 10 centimeter. That is telling you that what the object distance of the object is placed, which is u, is given to you as 10 centimeters. Then in front of a concave mirror has a positive focal length, which is f, is 15 centimeters. Then image distance, we have to look for the image distance. That is why you have what is the position. The position can be determined when you get the image distance. So how do we get the image distance here? You must recall the mirror's formula. 1 over u plus 1 over v equals to 1 over f. So u is 1 over 10 plus 1 over v unknown equals to 1 over 15. So if you collect the like times, you have 1 over v equals to 1 over 15 minus 1 over 10. So 1 over v equals to LCM here could be 30. 30 divided by 15, 2. 2 times 1, 2. Minus 30 divided by 10, 3 times 1, 3. So you have 1 over v equals to minus 1 over 30. And that shows that if you take the inverse, v over 1 equals to minus 30 over 1. That shows that v equals to what? Minus 30. So now the next question that follows is, what is the position and nature of the image form? Now this v here gives you the position. Now how do I get the nature? Now what is the nature? Now take note, the image has a negative sign. That means the object is real while the image is what? Virtual. 1. That is it. It forms an image that is what? Virtual. So the nature is it forms a virtual image. That is one question solved on that, which is example 1. Example 2. Example 2 now. So you have it that a concave mirror, I'll read out the question and just bring out the value. A concave mirror's of radius of curvature. Radius of curvature R has been given as 20 centimeters. Radius of curvature 20 centimeters produces an inverted image 3 times the size of the object. That 3 times the size of the object, 3 times represent magnification has been given as 3. So, but magnification is 3 times the size of the object placed and perpendicular to the axis. Calculate the position of the object and the image. That is, calculate the position of the object. That is, in this question, U is not given. Position of the object and position of the image is not given. So let me read out the question so that you can write it down. A concave mirror of radius of curvature 20 centimeters produces an inverted image 3 times the size of an object placed on and perpendicular to the axis, comma, calculate the position of the objects and the image. Alright, so one thing that we need here is the magnification. You must record that magnification is V over U. That shows that what you have been given magnification to be 3. So you have 3V over U, which implies that what V will be, if you cross multiply, 3U. Keep this. So recall that your mirror's formula is 1 over U plus 1 over V equals to 1 over F. But if you look at this question from up here, F is not given, but rather R is given, radius of curvature. So we note that radius of curvature is what? Twice 2 of F. That shows that F will be R divided by 2. So if you divide 20 by 2, that will give you focal length to be what? 10 centimeters. So anyway, we see F 10. So 1 over U is still U plus 1 over V is now 3U from here. V equals to 3U equals to 1 over F is 10. So take the LCM for this side. The LCM should be 3U. 3U divided by U, you are going to have 3 times 1, 3, plus 3U divided by 3U, so you are left with 1, equals to 1 over 10. So if you bring this here, that will give me 3 plus 1, 4 over 3U equals to 1 over 10. If I cross multiply, 3U will be 4 times 10, which is 40, and U will be 40 divided by 3, and that should give me the value for the U, 40 divided by 3 in centimeters. So, but you have an expression here that V is 3U, so you can use that to get V. So V will be, which is 3U, so V will be 3 times 40 over 3. 3 cancel 3, that means the image distance is what? 40 centimeters. So you have the value for V and U. So what can you say about this? V is bigger than U because 40 centimeters on its own is bigger than what? 40 divided by 3. So therefore the image has been what? Magnified, as if you zoom in a camera. Alright. So before I bring this lesson to an end, I would like you to work on the following as your assignment. That is, explain the following. One, chromatic aberration. Chromatic aberration and spherical aberration. Okay, how can this chromatic aberration and the spherical aberration, how can it be minimized? Then again, you should be able to define the following terms also: rectilinear propagation of light, luminous object, non-luminous object, or luminous body. And again, you should be able to state the principle of optical reversibility of light. The principle of optical reversibilities of light. It means the path of light rays are reversible. So once that is done, we'll meet again in the next class.